This is a Dog 68. It's a 35 millimeter camera, and it's really intended to be a documentary camera. So it's running at 28 frames per second, not really a high-speed camera. So it's almost real-time camera view. It's just a really beautiful shot, and because it's a documentary camera, we're able to enlarge the aperture so that the timing block isn't taking up image area, and present it in its widescreen view, and I think it's quite dramatic.
Yeah, from a beauty standpoint, this is probably at the top of my list for favorites. It's just gorgeous quality, fantastic color saturation, and very unusual. Shuttle photography is so beautiful. At the same time.
So Echo 55 begins our series of tracking cameras. Echo 55 is mounted on a kineto tracking mount, or KTM, which we commonly refer to it as, and it's located at CS1 about 1,200 feet from the vehicle.
This is a nice shot because you can see there's a bit of a distortion cloud here that we're shooting through, and what that is hydrogen being burned off from the fueling system. They burn off any excess hydrogen to safely combust it. So that's what we're seeing here, and it's really gorgeous as the vehicle sort of comes out of that and goes into its roll program, clearing the tower. Again, just a fantastically well-lit photograph on this thing. Some of the white things that you see falling off there are paper covers, which protect some of the order system engines. We'll talk about those later. But Kevin, these are all manually operated, right? I mean, there are human beings behind the scenes doing this tracking now.
Yes, this KTM, kineto tracking mount,
Hız
has
1600
4
km.
cameras,
Ses
that
duvarı
are
aşılmak
mounted
üzere.
on it. And this particular camera, Echo 55, is one of a pair of cameras, and is intended to look at the top half of the vehicle, while the other camera is intended to look at the bottom portion of the vehicle.
Right, and we'll see that in the next shot. We'll have one of the views from the bottom of the stack on the next one. In fact, our intent is to have in the deleted scenes on this disc a set of camera pair views sort of pieced together so you can see them simultaneously. So look for that in the extra features. This is fantastic. Now they're completely done with their roll program and sort of on their way.
Yeah, the intent of that camera shot is only for the first 1,200 feet of the ascent. Is really the intention of that view, and that takes about 18 to 20 seconds, I believe.
Okay, now this is camera 52, and this is, of course, is at the bottom of the stack now, so it's a little different view, and but part of a camera pair again.
Right. This camera is, as you said, is 52, and this is located on camera site 2. And it's about the same distance, 1,200 feet.
Nice shot of the SSMEs there. It always amazes me how transparent the exhaust coming out of the SSMEs is.
Now this kineto tracking mount
Yükseklik.
is
Metre
controlled by an
stratosfer
operator,
tabakasına
manually
giriş.
controlled by an operator who's sitting in the LCC on the second floor below the firing room. And the person, he or she, is using a trackball to track the vehicle. And it's pretty tricky because they're just looking at a little video monitor. And the vehicle is moving much faster in real time than we're seeing. We're seeing it at 1/5 the speed in this particular case of what it is in real time. This kineto tracking mount also has HDTV cameras that are used quickly. It's called quickly to look at these views in real time and then in near real time when we start the image analysis. Done while the film is being processed and transferred.
That was a fantastic shot, seeing the sun go right in between the two plumes. And in fact, it gives you an idea how bright these plumes are to the naked eye because the sun, as it passed through there, wasn't much brighter than the plumes that we saw. Wonderful shot showing the column of fire that the vehicle rises on, and it really contrasts nicely with the blue. Again, highlighting why STS-124 was really the correct mission to sort of springboard off of to show all the beautiful film.
This is camera 57. This is at CS6, again 1,200 feet from the pad or so. And we're looking at the bottom half of the vehicle. As I mentioned earlier, the camera is mounted on a tracker. KTM tracker has
Hız 4500 km. Yer çekimi ivmesi kuvveti artıyor.
Film camera looking at the bottom of the vehicle.
You see the paper covers below the RCS engines. Those are entire covers, just similar material that you would on your house when you're building it. And those covers are there in case they get a squall or a little storm while the shuttle's out on the pad. Not uncommon in Florida, and we can't afford to have water inside those engines, so we put those paper covers on there, and they have these little parafoils that inflate, sort of tear the cover off. They're just adhered with an adhesive of some kind. So you'll see a lot of that white paper coming off during these launch shots. Beautiful shot looking up the tail end of the stack. And possibly on the deleted features or the deleted scenes of this disc, we're going to try to edit these together, showing it to the camera player and use one of these together. You should look pretty nice. Look at that our deleted scenes feature on the disc.
This is Echo 225, and as you can see, it's already in flight. It's a really interesting view. It's a medium-range tracking camera. The mount and the camera are located at UCS-4, which is about 2.4 miles north of the pad.
One of the reasons I selected this shot to be included on the DVD is because I thought it was really striking and really beautiful how in their roll program, as they went into their roll, the sun sort of peaks over like it does here, and see the name pop out, and slowly the whole orbiter becomes lit with the evening sun. And the textures are fantastic. You can see the thermal blankets, you can see some of the thermal exposure to the thermal blankets. You
Yükseklik
see some variation in
80
color, and you
bin.
can see
Metre
the
mezot
tiles
katmanından
literally make
geçiş.
out the boundaries of the tiles there. So really a wonderful piece of footage and a remarkable contribution to the DVD from a photography standpoint.
The lens that's on the camera is a 150-inch sheer lens. It's a cat-eye dioptric lens, so it's got a mirror surface. And it's about 4,000 millimeters focal length if you converted the inches to millimeters. Just to give it perspective, Matt, the weight of this lens is about 250 pounds. Just the lens itself. It's a huge lens. And
You can really see a lot of nice textures on this shot too on the booster. If you look at the forward part of the booster, you can see the access panels and that big line coming off of the external tank. That's actually the oxygen feed line on the external tank. That's where that 280 gallons a second of liquid oxygen are flowing through to the main engines. That feed line is about 17 inches in diameter, so it's a pretty beefy system.
I think another thing to point out here is that this camera mount is manually tracked. So the operator is looking through a bore sight at the camera site, launch vibrations going on all around
Hız
him
kemer.
or her, and
Atmosfer
keeping,
sürtünmesi
that,
azalıyor.
vehicle dead center in the frame. It's quite amazing feat to be able to do that so quite so accurately.
Yeah, they've done a great job of keeping it on target every step of the way. Now they're getting a little further away, obviously, and you can see sort of the glow of those engines starting to come up against the bottom part of the stack there, as they call it, and that's showing something's going on at the back end of that vehicle.
So the next series of shots we're going to see is views from the HD cameras. And in this particular view, this is from STS-114 Return to Flight. So this was in July 26th of 2005. And we're about 2 miles from the pad, just south of pad 39B here. And the camera is cocked at a 45-degree angle to enable maximum use of the 16:9 aspect ratio that is available with the HD TV cameras.
Now it's important our viewers take a good look into the left window there. You can actually see Eileen Collins, who commanded this mission. You can see her suit inside the window. Absolutely amazing. And this is a first, right? This is a first in the program. We started using high-definition video after Columbia, and that was one of the first times we saw this level of detail in photography.
That is correct. So this particular camera view is EHD 225. This was recorded on STS 170.
Yükseklik 100 kilometre hattı. Resmen uzay boşluğuna
The
girildi.
camera is running at 60 frames a second, as all the HD 3D cameras do. Orientation of the camera is cocked at 45 degrees to make maximum use of the aspect ratio of the 16 by 9 frame to get as much of the vehicle, space shuttle vehicle in the frame as possible.
This particular shot I chose because it's well exposed and it shows a beautiful sequence in the roll program, but you also get this really nice vapor phenomenon as the vehicle accelerates to higher speeds. And this is not always visible to the for every launch. It's a consequence of atmospheric conditions, dew point, humidity, etc. So I thought it was kind of a nice touch to this particular image. This is the only long-range camera that made the final cut, and Kevin will give you the details about that in a moment, but I want you to look at the bottom of the tank there. As you saw, it just sort of became engulfed in flames. And you should know that this is a normal phenomena in a shuttle launch. What's effectively occurring here is the exhaust gases coming out of the SRBs and the SSMEs are sort of expanding into the higher vacuum as they head into space. And the radiant heat from the expanded plumes becomes high enough to ignite some volatile gases that are caught up in this aerodynamic dead zone, so to speak, at the rear of the tank for a couple of moments during flight. But this is an amazing shot, Kevin, because it's from so far away, so why don't you explain what we're looking at here?
Yeah, Matt, the camera here is located at a place called Apollo Beach. It's within Cape Canaveral National Seashore. And the camera mount is about 20 miles north of the pad, so it's quite a distance away. This is a Brashear 150-inch lens, again about 4,000 millimeters. So quite a distance, and the tracker, as we mentioned earlier, is manually operated. So it's an operator looking through a scope and using a trackball to keep the vehicle in the field of view. It's also difficult for the operator, because of the distance, to see the vehicle at launch to sight the pad.
Hız, kemer, yörüngeye giriş, yörünge hızı sabitleniyor.
Quite a skill level that needs to be developed in order to do that.
Well, and of course we watched our solid rocket boosters separate, which is sort of at the tail end of what we can see with all of the tracking cameras. And there you see our boosters coming off, and they separated about 29 miles in altitude, about 2 minutes into flight, and they are recovered by divers out in the Atlantic Ocean. And although they appear to be falling back here, they're actually traveling another 15 miles or so up, just tumbling on their own forward momentum before they peak and then come back down in the Atlantic about 150 miles out, where the diving teams pick them up and bring them back for refurbishment. So this sort of brings us to the end of our production. Hope you guys have enjoyed the commentary. Kevin and I have enjoyed doing it today for you. And
Sıcaklık, uzay aracının dış yüzeyinde eksi 150 santigrat derece ile 120 santigrat derece arası değişim. Görev başarılı, alçak dünya yörüngesine yerleşildi.